Hello. Let's talk about graphing sine and cosine functions. Let's first start by completing the table for y is equal to the sine of x. So you have the x values. Notice the angles are all in radians. You should know those from your unit circle. So take a moment to fill those in. So hopefully you paused it and fill these items in, so you should have the following values. So now, what we are going to do is actually plot those points. So let's start with 0, 0. Pi over 2 and 1. Pi 0. 3 pi over 2 negative 1. And 2 pi 0. So whenever you're graphing the sine or cosine function, you will plot 5 points. So these, you can say that this will be our parent graph for this particular function, and everything else will have a certain transformation, be it left, right, up or down. There will be a stretch and compression. We'll talk about those as we go along. This is our parent graph. Notice this is, there's no my drawing. It's not the best. That it is curved, not pointed. It is curved. Okay? So, as we talk about what our domain is for the sine of x. Our domain, this is continuous. So it's going to go from negative infinity to infinity. It does not stop and start here. This keeps going. That keeps going. Okay? Our range, however, doesn't get any lower than negative 1. Doesn't get any higher than 1 for this particular function. Okay? So notice the brackets indicating that negative 1 and 1 is included. Okay? So this is the graph of our parent graph for sine. So I want you to pause, take a moment, and fill in the table for cosine. Okay, so if you, again, noticing that the angles are in radians, filled in the values for the cosine of x, you should have the following values. So once again, we are going to plot our 5 points. Okay? So, unlike sine, where we started with 0, 0, with cosine, we start at 0, 1. Then we go to pi over 2, 0. Then we go to pi negative 1. 3 pi over 2, 0. And we finish at 2 pi and 1. So again, this is a curve. It's not a V. It's not pointy. It's curved at these values, and it is continuous. So it's not a stopping point, which means for our domain, for sine, it is still negative infinity to infinity, and our range, the bottom is still negative 1 with the bracket, and the top is still 1. So what I want you to do right this very moment is turn your calculators on. Press mode. And make sure your calculator is in gradient mode. So if it's not, just go to radians, make sure you highlight it, press enter. Next, press Y equal. Let's first put in the sign of x. Press enter and graph. It doesn't quite look like what we see. So we want to go to window. And we want to change our window. And let's make the x minimum 0. And let's make the x maximum, let's say 3 pi. And make the x scale right now, let's make the x scale pi divided by 4. We can always adjust that if we so choose. And then graph. So let's go back and change our window again. For world y, let's make our y -2 as the minimum, and let's make the maximum 2. So we can have a much better picture than what we're seeing. So if you want to see exactly what is on your paper, obviously you'll press window and we can make our x maximum 2 pi. And see what's on your paper. Okay? So y equals, let's take a look at cosine x. You'll get that visual of what that looks like. Pretty much the same thing we just did. So now let's look at our next page of notes. Even and odd function. So the even functions is the function when f of negative x is equal to f of x for every x in the domain of f. So even functions are symmetric with the y-axis. That means when the right side of the y-axis is a reflection of the left side, the graph is symmetric. Which graph is symmetric with the y-axis? So if we go back to the previous page, which one looks like it's going to be symmetric with the y-axis? Now we'll go ahead and tell you that it is cosine. So cosine is an even function. Okay? Because from our previous unit, we know that cosine of negative x is equal to cosine of x, just like x squared is the same as negative x squared. You square negative, you're going to end up with positive. Okay? So that means that sine is our odd function. Okay? Give you a minute to get all this down. Right here we know that the sine of negative x is equal to negative sine x. We've talked about that before as well. Okay? So now, let's go back to our calculators. Let's look at f of x equals a times the sine of x. And we know from a previous unit where a was letting us know whether there was a stretch or compression. Right? You know that from our quadratics most recently. So in your calculator, sine in y1, do sine of x, and in y2, do 4 sine of x. And then answer the following questions. So if we put those two functions into y equals sine of x and 4 sine of x, and we graph them, so we get a visual of what they look like. Notice the difference in our graphs. So from looking at that, does the x-intercept change? It's still crossing x at the same point, so let's say no. Does the y-intercept change? We still see that it's crossing at the origin, so we're going to say no. Does the domain change? It's still negative infinity to infinity, so we're going to say no. However, does the range change? Clearly, 1 and negative 1 are not the top or bottom anymore, so that does change. So now, if we change our window, so let's change the y min and max to negative 5, and then graph it. We see our original, and there we see 4 sine of x, so what does our range now become? The domain's the same, negative infinity to infinity, but now the range is from negative 4 to 4. So that is the impact of A on our graph. Just like the previous functions we talked about, A is telling us whether it stretches or compresses. Okay. So if you need to go back and kind of watch this again, that is fine. But you can look at graphing sine and cosine part 2 to get the remaining portion of the